My goodness, what is this? Chapter 2, we made it, guys. We got one chapter down and only about 8 or 9 left. We are 1/8 to 1/9 the way through this school year. So that is pretty incredible. I don't know what that's supposed to be a face. It's a very strange face. But let's talk about what chapter 2 is going to be all about. So chapter 2, fun fact, there are 6 days in chapter 2. Only 6 days. That means it is the second shortest chapter of the year. What's the topic? Well, it's going to be all about inequalities. And if you're wondering about inequalities, take a moment to read this right here. We're going to work on solving them, just like we solved equations. And in fact, these play out much the same way as solving a linear equation. They are very, very similar. The main difference is we're going to be required to graph the solution on a number line. So basically, guys, with an equation, you have maybe x equals 6. With an equation, you have, I just came up with this, x equals 6. Now, if you were to plot this on a number line, here's 6, 7, 5. Remember, as you go to the right, the numbers get bigger. You go to the left, the numbers get smaller. If I were going to graph this answer on a number line, it'd look like that. It would just be a dot. X equals 6, that is the one solution right there. But when we graph an inequality, that's when we bring in all the different symbols. Like, for example, x is greater than 6, which is how we would read this. X is greater than 6. So if you had a number line, 6 is in the middle, let's say, 7 was there, 5 was there. Again, you don't have to put 0 in the middle of this number line. You can start a number line from anywhere. Here's the thing. If x is greater than 6, we put an open dot because it's not equal to 6, right? X is equal to 6, closed dot. X is greater than 6, we have an open dot. And where are all our solutions? Where will we shade? Because with an equation, we shaded at 6. If it's greater than 6, we shade where the number's bigger. Where are the numbers bigger? Oh, it's to the right. Yeah, we shade 7, 8, 9, 10, 11, 12, so on and so on. And so that's really what this chapter is going to be all about, solving linear inequalities, graphing linear inequalities, and being able to write a linear inequality from a given statement. Now, compound inequalities, we're going to talk more about compound inequalities on day 2. So hang tight on that one. Hang tight on that. But yeah, so we solve these just like an equation. So go ahead, guys. Look at number 1 and number 2. Solve like an equation. The big thing is we're going to have to graph this. But we'll worry about that in a second. So what would you do if you were going to solve this? Remember our steps? Mode distribution. Combining like variables. We have a 3x there and a 4x there. Do you guys think we should subtract the 3x over or subtract the 4x over? I'm with you. Let's keep the number with x positive and let's bring 3x over. So we subtract it and you get 8 is going to be greater than or equal to 4 minus 3. That would be x. So here's the thing. You could read this 2 ways. 8 is greater than or equal to x, or x is less than or equal to 8. Another way to write this could be flip it. Move that over there, flip the sign. There you go. So this would be x is less than, oh, but wait a minute. What's that sign down there? That is an equal to sign. That means x could also be 8. X is less than or equal to 8. Now, you don't have to write this beside every answer. I'm just doing this so you guys can remember what this represents. And speaking of what it represents, let's get a number line. We got 8 here, 9 here, 7 here. We have a circle at 8. Now, will this circle be open or closed? Ooh, it's going to be closed because x is less than or equal to. It could be equal to 8. Now, if x is less than, which way are all the numbers less than? Right or left? Less than would be to the left. And let's take a moment, guys, before I let you try number 2. Let's take a moment to talk about the different signs. So again, we can read these two different ways. Normally, if you have x like that, we say this is x is greater. If you have it written like this, we would say a is less than. If you had, what if you had it written like that? Guess what? This is still x is greater than. In this case, 3. What if you had it written this way? 4 greater than a. Well, guess what? That is still a is less than 4. You could read it right to left or left to right. Those are the same thing, and those are the same thing. And so, guys, go ahead and try number 2 for me. Actually, you know what? Let's work this together. I apologize. Because I think we do need to do one more together. How about this? We've got r is being subtracted by a negative 5. Wait, isn't that a double negative? Yeah, that's really plus 5. And so if that's really plus 5, let's subtract 5. And so r is going to be greater than 2 minus 5. That's a negative 3. So if you want to make a number line, we'll put negative 3 in the middle. And don't forget, I'll make a little note here. The bigger the negative number, the smaller its value. Don't forget, guys, the bigger the negative number, actually the smaller its value. So negative 4 is smaller than negative 3, and negative 2 to the right is bigger than negative 3. We'll put a circle at negative 3. Will this be an open dot or a closed dot? If r is greater than negative 3, that means it's not equal to it. So we can't fill that in. Instead, we're going to shade to the right, where all the numbers are bigger than negative 3. Because remember, the variable represents all the values that are bigger than that. And so now I'm going to let you guys try 1, 2, 3, and 4 for me. Go ahead and give these a shot. Okay. So you can see, number 1, I added 15 over because we want to get everything away from x. Ooh, that gave me x on the right side, which normally is fine. But we're going to talk about here in a second, if the variable is on the left side, we can actually just know that the shading follows which way the arrow is pointing. So I flipped everything. I said, let's bring x to the left. Let's bring 7 to the right. And if we do that, we have to flip that sign. So x is less than or equal to 7. Same thing on number 2. I subtract 4x over. I get x is greater than 3, which I then write like this, so that x is on the left side. Subtract 7x over. Hey, this time we get to get x on the left side to start. So subtract 7x over. 8 minus 7 gives you 1x, which is greater than negative 4. And then I subtract 12 over to get it away from x. So x is going to be less than or equal to 9 minus 12 is negative 3. And so again, I want to bring your attention back to this right here. You notice how in all of the boxed answers, I made sure that x was on the left side? Well, the reason I did that is because now you can just follow the arrow for our shading. So if x is less than or equal to 7, let's look over here. Where do we see a dot at 7? Boom, right there. Is it a filled in dot? Yes, it is, because x could be 7. It could be equal to 7. So we fill that in. It's part of the shading. And then are we going left? Is the shading following our arrow to the left? Yes, it is. So number 1 is B. How about number 2? X is greater than 3. So we need a point at 3. So we got -3 and 3. It's going to be this one. It is an open circle because that is not equal to 3. It's greater than 3. And x is greater, so we're going to the right. So that would be D. Number 3, x is greater than -4. There's -4 with a point open because x is greater than, not equal to, and then we're shading to the right because x is greater. So greater to the right. So that would be A, which leaves number 4, x is less than or equal to -3. Filled in at -3 going left. That would be C. So B, D, A, C. And again, just a reminder, open circle, we're talking greater or less than. Closed circle, we're talking greater than or equal to or less than or equal to. Just a friendly reminder there. And so guys, let's wrap up with this. We want to be able to write an inequality by defining a variable and then being able to write a given statement using an inequality, where we're going to have some mathematical operations. We're going to have some adding, subtracting, multiplying, dividing. This is just like what we did back in chapter 1. So define a variable, write an inequality, plain and simple. So I'm going to call all my variables. I'll let all my variables either be A, B, or C. I'll kind of alternate between those. So the sum of a number, well, we don't know that number, so I'm going to call it A, and 17 is no less than 26. So the sum, we're talking plus, so A plus 17, and then here's the phrase right here, is no less than 26. So we know we're going to have 26 over here. The question is going to be, what sign goes here? Well, if I tell you to run no less than 5 miles, that would mean you better be running 5 miles or more. No less than, that's the opposite of less than. If you see the word no in front of it, that means it's the opposite. Well, what's the opposite of less than? That's going to be greater than or equal to. So A plus 17 is greater than or equal to 26. How about number 2? Twice a number. Okay, if we're doing twice a number, that means we're multiplying something by 2. I'm going to go B this time. So twice a number, 2 times B, minus 4. Minus 4 is, here's the key word, less than. So if it's less than, then we'll rock in less than 3 times, sorry, I didn't mean to go with that, 3 times the number. So 3 times, what did we call our original number? Oh, that was B. Let's check it out. 2B minus 4 is less than 3 times B. I'm going to let you guys try numbers 3 and 4. And then we will wrap up part 1 of day 1. So the key with 3 and 4 is to look for the word is, because that's going to tell you what will go in the middle. It's going to prelude whatever comes next that will be the sign in the middle. So we've got is at most. So think about it. If I told you to run at most 3 miles, at most, let me write this over here. At most really means less than or equal to. What's the opposite phrase of that? Oh, at least. That's going to mean to do that much or more. No less than, we know, was talking about greater than or equal to. How about no more than? When you see that phrase no more than, what symbol are you thinking of? If I told you to run no more than 3 miles, that's the opposite of more. So that would be less than or equal to. So if we're talking 12 is at most, that's going to be a less than or equal to. And again, that word is sets us up for what's to come. How about this one? 8 plus 4 times a number is greater than 5 times that same number. All right. And so that is the end of part 1.